Hello everyone, welcome to this class. Today we're going to be discussing matrix, transpose of matrix, addition, subtraction, multiplication, and how to find the determinant of a matrix. If you are new here, please do not forget to subscribe and turn on the notification bell so you'll be the first to get notified when I drop a new video. So let's say for example we have something like A1, 1, A1, 2, A2, 1, A2, 2. Alright. So matrix is the arrangement of numbers and letters in rows and columns. So looking at this, we see that the rows is one going like this, columns is one coming down. So we have two rows. This is our row, and then like this is our column. So A11 means row 1, that is row 1 going like this, and then column 1. So the A11 is on row 1, column 1. A12 is on row 1, then column 2. This is your first row, this is your second row, this is your first column, and this is your second column. So A12 means that A is on row 2, which is the second row, and on column 1, which is the first column. So this is how you can represent a position of each element. Row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. So there are different types of metrics. We have the row matrix, rows matrix, so row matrix is a kind of matrix that has just one row and multiple columns. So for example, we have something like and we could go on. So this is an example of a row matrix. It has just one row, but it has multiple columns. These are the columns, but it just has one row. So a row matrix has one row and multiple columns. Then we have the column matrix. It's just an opposite of the row matrix. In column matrix, we have just one column but multiple rows. For example, we have something like this. Okay, this is an example of a column matrix where it has just one column but multiple rows. So this is what the column matrix is. And we also have the square matrix. A square matrix is a matrix that has equal numbers of rows and columns. For example, of square matrix, we have 1, A, 1. This has 2 rows, and 2 columns. So this is an example of square matrix. This is basically 3 types of matrix. Okay, now since we are done with the types of matrix, let's move on to other forms of matrix like the transpose of matrix. So what transpose is just talking about is changing your rows to your column. That's what transpose is all about, and is written as AT, which means A transpose. So you might be giving your A as, let's say, 1, 2, 3, 5, 6, 8, 4, 7, 9. And then you have to find your A transpose. So it's all about changing your rows to your column. So your A transpose will be equal to your first row is 1, 2, 3. Now you have to change your first row, you turn it into your first column. By the time you do that, you have 1, 2, 3 as your first column. It's just be here. We turn our first row to our first column. We do the same to our second row. We change it into our second column. We have 5, 6, 8. Now our third row, we turn it into our third column, which is 4, 7, 9. So that's it. This is how you find the transpose of a matrix. You just change your rows into columns. That's it. Okay, so that will be all for transpose. Now let's move into addition and subtraction of matrix. Okay. So in addition and subtraction of matrix, the number of rows and columns of A should be equal to the numbers of rows and columns of B. So if you are given something and you are asked to find the addition and subtraction of A and B, if you have to find A plus B and A minus B. So A plus B would be equal to. So in addition, what you have to do now is to add your A11 to your A11 in B, and add your A12 in A12. Your 1 plus 2, that's 3. 2 plus 4 will give us 6. 3 plus 3 give us 6. 5 plus 4, 9. 6 plus 4, 12. 8 plus 1, 9. 4 plus 2, 6. 7 plus 4, 11. 9 plus 2, 11. So that's the addition. So for your subtraction, 1 minus 2 give us minus 1. 2 minus 4 give us minus 2. 3 minus 3, 0. 5 minus 4, 1. 6 minus 4, 2. 8 minus 1, 7. 4 minus 2, 2. 7 minus 4, 3. 9 minus 2, 7. So that's it for addition and subtraction of matrix. Next, let's move into finding the determinant of matrix. The sign for your determinant of matrix is you have 2 slash, then in between you have your D. So determinant is subtracting your major diagonal from your minor diagonal. So let's say we have A equal to 1, 2, 3, 4. And determinant is major diagonal minus minor diagonal. Where your major diagonal is your A11 and your A22, and then your minor diagonal is your A12 and your A21. So what you have to do now is to multiply your A11 by your A22, multiply your A12 by your A21, and then you subtract it together. That is, you go like this, you multiply this, you multiply this, then you subtract it. 1 times 4, we have 1 times 4 minus 3 times 2, 3 times 2. 1 times 4, 4 minus 3 times 2, 6. So your determinant for A would be equal to minus 2. So you could also be asked to find determinant for a 3 by 3 matrix. That is a matrix with 3 rows and 3 columns. The one we just did has 2 rows and 2 columns. So if you want to find something for 3 rows and 3 columns, let's do that. So if you are giving an example, 7, 4, 2, minus 6, minus 5. So if you are given something like this and you are asked to find your determinant, First thing you need to do is to break it down to a 2 by 2 matrix. So you can then use your minor and major to find determinant. So how do you break it down to a 2 by 2 matrix? First you need to know that there's an invisible plus here, there's minus, and then there's plus here. So what you're going to do now, your 7 minus 6 and 3, your first row, you pick 7. If you pick 7, which is your A11. Now, since you pick 7, everything that is below 7 and everything that is by the side of 7, that is everything that is on row 1 and on column 1, it will be eliminated. That is, you strike them out like this. And then you'll be left with minus 5, minus 4, 1 and 8. Minus 5, minus 4, 1 and 8. That's for 7. Now you come to 6. You come to your 6. This minus here will cancel this minus to 6. So you have plus. By the time you eliminate everything that is on the first row and everything that is down below 6, you have you clean this side and then you clean here straight. What will be left will be 4, 2, minus 4 and 8. So you see that by the time you clear here and then you clear your first row, you'll be left with 4, 2, minus 4 and minus 8. Now you do the same thing for 3. Plus 3. You clear everything that is here and you clear everything that is here, you'll be left with 4, minus 5, 2, 1. So you see that from here you can find your major diagonal and your minor diagonal. So you have 7, open bracket, minus 5 times 8, minus 1 times minus 4, 1 times minus 4, plus 6, 4 times 8, minus, open bracket, 2 minus 2 times minus 4, plus 3, open bracket, 4 times 1 minus 2 times minus 5. So what you need to do next now is to multiply each of them. Minus 5 times 8 will give us minus 40. Minus 1 times minus 4, minus 4, plus 6, open bracket, 4 times 8, minus 2 times minus 4 will give us minus 8. Plus 3, 4 times 1, 4, minus 2 times minus 5 will give us minus 10. So next now we subtract. minus and minus is plus, so minus 40 plus 4 will give us minus 56 plus 6. 32 minus times plus is plus, 32 plus 8 will give us 40. My 4 minus 10 minus and minus is plus, so 4 plus 10 gives us 14. Now 7 times minus 36 will get minus 252 plus 6 times 40 get 240 plus 3 times 14 get 42. Now minus 52 plus 240 plus 42 will give us 30. So these are determinants. These are defined determinant of a 3 by 3 matrix. Now let's move on to multiplication of matrix. So let's say, for example, we have our A equal to and then our B remember, in multiplication, order matters a lot. If you are being given A as 2 rows, 3 columns, then your B should be 2 columns, 3 rows. Let me write it together. If your A is 2 by 3, that is 2 rows and 3 columns, then your B should be 3 by 2, that is 3 rows and 2 columns. So in multiplication, the order of arrangement matters a lot. So now what we want to do now is to multiply our first row by our first column, multiply our first row again by our second column, and then multiply our second row by our first column, and then still multiply our second row by our second column. So A times B will be equal to 2 times 2, that's 2 times 2 plus 3 times 2 plus 1 times 4. Then now you come to the other side, multiply this same row, this same first row by the second column. You have 2 times 2 plus 3 times 3 plus 1 times 2. Now you come to your second row and use it to multiply your first column and then your second column. So we have 2 times 2 plus 1 times 2 plus 1 times 4. Come to the other side. We have 2 times 2 plus 1 times 3 plus 1 times 2. So now you just multiply it, each multiplication, then you add them. 2 times 2, 4 plus 3 times 2, 6 plus 4 times 1, 4. 2 times 2, 4 plus 1 times 2, 2 plus 1 times 4, 4. 2 times 2, 4. 3 times 3, 6. 1 times 2, 2. 2 times 2, 4. 1 times 3, 3. 1 times 2, 2. Now you add. 4 plus 6, 10 plus 4, 14. 4 plus 2 plus 4, that's 10. 4 plus 6 plus 2, 4. 4 plus 3 plus 2, 9. So our A plus B, A times B. So these are your find multiplication. Next, let's look into inverse. How to find inverse for matrix. So inverse is written as, just ask find A inverse is written as A to minus 1 on top. And the formula is 1 minus A determinant, where 1 is each element in the matrix divided by your determinant. So let's say, for example, we have A equals, I mean asked to find the inverse of this. First thing you need to do is to find your determinants. Multiply your major diagonal by your minor diagonal and then subtract them. So we have 3 times 2 minus 7 minus 7 times 5. 3 times 2, 6 minus 7 times 5 is 5 minus 35. Minus and minus is plus. So 6 plus 35, we have 41 as our determinant. So after finding the determinant, now we just put into the formula. The formula says each of the elements whole over 41. So your A inverse will be equal to 3 over 41 minus 7 over 41, 5 over 41, and 2 over 41. So this is the final answer. This is your inverse. Okay, so the formula for solving the cofactor of the matrix, and the formula is So your minus 1 comes with the formula. Your R is equal to the row of the element you want to use. Then your C also equal to the column of the element you want to use. Then your N is the matrix or the element that you are using. So now let's solve something with it. So for example, we have A equal to so now let's put this into our formula. So we have minus 1 times 1 close the bracket. 1 is on the first row. 1 is on the first row, second column. Remember these are your rows. Rows. And these are your columns. Columns. So 1 is on row 1, column 1, so it will be 1 plus 1. Another bracket minus 1 times 2. 2 is on row 1, column 2, so it will be 1 plus 2. Another 1 minus 1 times 3. 3 is on row 1, column 3, so it will be 1 plus 3. So now we note our second rule. Okay, so we have the bracket minus 1 times minus 4. Row 2, column 1, row 2 minus 2 plus 1 minus 1 times 5. Row 2, column 2. Row 2, column 3. Seven is on row 3, column 1. So 3 plus 1. 8 is on row 3, column 2. So 3 minus 3 plus 2. 9 is on column 3, row 3, column 3. So now we add the power of 1. Let me clean up the so you can see better. One plus one is 2. 2 plus 1 is 3. 1 plus 3 is 4. 2 plus 1 is 3. 2 plus 3 is 5. Minus 1 times 7. 3 plus 1 is 4. 3 plus 2 is 5. 3 plus 3 is 6. So this is CA. We still haven't found the final answer. This is our end. Now next we want to do multiply minus 1 by the power. It's carried. So minus 1 is the power of 2 will give us plus 1. We have 1 here times 1. Minus 1 is the power of 3 is still minus 1 times 2. Minus 1 is the power of 4 is plus 1 times 3. Minus 1 raised to the power of 3 is minus 1 times minus 4. Minus 1 to the power of 4 is plus 1 times 5. Minus 1 is the power of 5 is minus 1. Minus 1 is the power of 4 is plus 1. Minus 1. Okay, minus 1 is the power of 5 is still minus 1 times 8. Minus 1 is the power of 6 is plus 1 times 9. So we're almost there. 1 times 1 is 1. Minus 1 times 2 is minus 2. 1 times 3 is 3. Minus 1 times minus 4 is plus 4. 1 times 5 is 5. Minus 1 times 6 is minus 6. 1 times 7 give us 7. Minus 1 times 8 will give us minus 8. 1 times 9 give us 9. So this is your answer. This is how we find the cofactor of any matrix. So that will be all on matrix. If you are new here, please don't forget to subscribe and turn on the notification bell so you will be first to get notified when I drop a new video. So that will be all. Thanks for watching.